Hello students, in this video lecture we will discuss find moment generating function, mean and variance of binomial distributions. So before we solve this problem, first we recollect what is binomial distribution. The binomial distribution of a discrete random variable capital X is nothing but P of X equal to probability of capital X equal to small x, that is nothing but NCX P power X Q power N minus X, that is equal to X varies from 0, 1, 2, 3 etc. N. This is nothing but set of all non-negative integers. And also recollect what is moment generating function of binomial random variable, that is nothing but mx of t equal to expected value of e power tx, that is equal to summation x equal to 0 to n e power tx into p of x. Using moment generating function along with given probability mass function, we are going to find moment generating function, mean, variance and standard deviation of binomial distributions. Okay, solution, right? So what is given? Given statement is binomial distributions. So we know binomial distribution is what? Probability of x equal to capital P, capital X equal to small x, that is equal to what? NCX P power x Q power n minus x, comma x varies from what? Set of all non-negative integers, that is 0, 1, 2 up to n. Okay. So here we know what is meant by C. C is nothing but combination. That means we are going to choosing the things. Otherwise, we are going to selecting the things. Okay. And also, we can write what? What is NCX for n factorial by x factorial into n x whole factorial. Okay. So now we are going to find step number 1. What is step number 1? We find the moment generating function of capital X. Capital X is nothing but random variable. Okay. So here the given distribution is what? Binomial distribution is always discrete distribution. So we consider moment generating function of this discrete distribution is nothing but expected value of e power t capital X, that is summation capital X e power small x into p of x. So here capital X is there, replace capital X equal to what? Small x. Okay. So now that is equal to what is given limit? We know capital X equal to what? Small x. Small x values. What are the small x values? 0 to n. So we consider equal to 0 to n e power tx. What is p of x? That is given function binomial distribution ncx p power x q power. Okay. So now I am going to arrange the term of power term. Okay. Here power x is there. Here also power x is there. Right. The above step is summation x equal to 0 to n ncx. We can write the term is e power t whole power into q power n minus x. Okay, if you multiply p into x, p power x, if you multiply e power t into x, that is nothing but e power tx. Okay, okay. So we know that but p plus q whole power n equal to summation x equal to 0 to n ncx p power x power n minus x. So this is nothing but binomial expansion. Okay, so using binomial expansion and our step, here you see what is p value. Here p power x is there. So here we have p e power t whole power x. Q power n minus x is there. Here also we have q power n minus. So p power x means coming to left hand side, we write what? Only p. Q power n minus x can be written as q. Okay. So here what is our p value? Our p is nothing but t e power t. So using binomial expansion, we get p e power t plus q. Q is nothing but q whole power. So this is called what? Moment generating function of binomial random variable. Okay. Okay. Step number 2, to find what? Mean. Okay. So we know that mean formula is nothing but mu equal to expected value of capital X, that is equal to what? M dash of t, substitute t equal to 0. Okay. So we know So we know in previous step, what is mx of t value? P e power t plus q whole power n, right? So first I am going to find the first derivative, that is nothing but m dash of t equal to, how to differentiate this? We know what is differentiation of x power n, that is nothing but n x power n minus 1. After that, when you differentiate x, you get 1. So using x power n formula, we can write this n into p e power t plus q power n minus 1. After that, differentiate with respect to t once again. So we get what? P differentiation of e power t means e power t plus differentiation of constant, you get 0. Okay. So that is nothing but n p e power t plus q power n minus 1 into p e power t. Okay, so here n and p is what? That is binomial parameter, that is we consider constant. So we get np into p e power t plus q power n minus 1 into e power t. Okay, so this is called mx dash of t. Now I am going to find the mean value, that is mu equal to m x dash of, substitute wherever t equal to 0. Okay, if we substitute t equal to 0 in previous equation, we get what? Np into, substitute t equal to 0 here. If we substitute t equal to 0, what is e power 0? 1. So we get p plus q power n minus 1. If we substitute t equal to 0 here, we get what? Into 1. That is nothing but np. We know that what is p plus q? P plus q is nothing but 1. 1 power n minus 1. We know 1 power anything but 1. So we get np. Okay. So therefore, what is mean of binomial distribution is mu equal to np. Okay, next we find step number 3. What is step number 3? To find variance of x. Okay, so we know that variance of x is nothing but what? Expected value of x square, expected value of x whole square. Okay, this is variance of x. Okay, in previous step, we know what is e of x. E of x is nothing but mean value, we know, but we don't know what is e of x square value. Okay, so next our target is, I am going to find what is e of x square. That means expected value of a binomial random variable x whole square. Okay, so that is nothing but, what is our formula? mx double dash of t, substitute wherever t equal to 0. Okay, in previous step, that means step number 2, already we found what is m dash of t value. Okay, m double dash of t means once again differentiate with respect to t. In this equation, if we get some answer, after that substitute t equal to 0, we get e of x square. Okay, so how to differentiate this function? Here np is constant. Okay, here also t is there, here also t is there. I'm going to apply product rule. You consider this is u, this is v. Okay, what is d by dt of u v formula? U into v dash plus v into u dash. Okay, so using product rule, I am going to differentiate with respect to t once again. So we get np into, so you consider u as it is, that means p e power t plus q whole power n minus 1. What is differentiation of v? That means what is differentiation of e power t? So e power t. Okay, plus we consider same value, that is e power t. Differentiate with respect to t in u term. Okay, so here you consider this is x power n is there. We know x power n means n into x power n minus 1. Same model we get n minus 1 into p e power t plus q power n minus 2. Once again differentiate with respect to t in the given function. So we get p e power t plus 0. Okay. So now substitute t equal to what? Wherever t, substitute t equal to 0. If we substitute t equal to 0 in this equation, we get np into, substitute t equal to 0, we know e power 0 equal to 1. So we get p plus q power n minus 1 into 1. Coming to this term, e power 0 means 1, 1 into n minus 1. If we substitute here, we get p plus q power n minus 2 into p. Okay. So now you simplify this. We know that p plus q equal to what? What is p plus q? Probability of success plus probability of fail is equal to 1. So we get np into 1 power n minus 1 plus n minus 1 into 1 power n minus into p. Okay, so we know that 1 power anything what? 1 power anything equal to 1. So you get np into 1 plus n minus 1 into p. If you multiply these two terms, we get np into 1 plus np minus p. Once again you multiply these two terms, we get np plus np whole square minus np square. So this is nothing but what? Expected value of x square value. Okay. So now we substitute expected value of x square and expected value of x in variance formula. Okay. So we know that variance of capital X equal to what? Expected value of x square minus expected value of x whole square. Okay. So what is expected value of x square? So that is nothing but np plus np square minus np square. Okay. Substitute here. We get np plus np whole square minus np square. We know expected of x is nothing but that is mean value is np. Okay, so np whole square minus np square plus np square are getting cancelled. You get remaining value np minus np square. Okay, so here np is common. If we take outside from this equation, we get np into 1 minus p. Okay, since we know that p plus q equal to 1, we can write this q equal to what? 1 minus p. That means 1 minus probability of success. Okay, if we substitute here, we get npq. Okay, that is nothing but variance of x. Variance of x, it is also denoted by sigma square. Okay, so what is standard deviation? We know standard deviation is nothing but square root of variance of x, that is equal to square root of sigma square equal to what? Square root of npq. Okay, and also standard deviation, it is denoted by sigma. Okay, hence what is m? A moment generating function of binomial distribution is what? P e power t plus q whole power n. Okay, what is mean of binomial distribution? That is np. What is variance of binomial distribution? That is nothing but sigma square equal to npq. Okay, and standard deviation of binomial random variable is what? Sigma equal to square root of npq. Okay, I hope you are enjoying this session. Thank you.